Hello folks, this is a transformation video on dilation. So we're going to be talking about dilation. Take out your MSR 10 note sheet. Here we have a picture that we're going to be looking at, and we are going to be dilating this figure. So what we're going to do is we're going to start, and we're going to actually dilate the figure by 2. So we're going to dilate this by 2, and what that means is, I don't know if you've ever gone to the eye doctor, but they can put something in your eye that makes the pupil of your eye get larger, and that's called dilating your eye, which basically means it's larger and easier for the eye doctor to look into and see if there's any issues or anything. So dilate is something that means to change the size. So we might see this figure change size. All right, so the first thing we need to do again is to write down our starting coordinates. So let's go ahead and record those. So A is at 2, 3. We've got B, which is at 1, 2, 3, 4, 5, 1, 2, 3, 4. We've got C, which is at 5, 2. And then we've got D, which is at 1, 1. All right, so what we do when we dilate is actually really similar to the distributive property. I like to think about it almost like the distributive property. Because when we dilate, we are going to multiply both of the values in the coordinate by 2 in this case. If the dilation was by 3, then it would also be by 3. So in this case, I'm going to multiply by 2. So I'm going to multiply 2 by 2, which I know is 4, and then 3 by 2, which is 6. And now I'm going to graph this coordinate 4, 6. And there we go. So I'm going to call that A prime. And then I'm going to do the same thing again. This time it's 5, 4. So for B prime, I'm going to have to multiply both of them by 2. So I get 10, 8. So now I'm going to go into the house 10, 1, 2, 3. And then up 8, which would be right here. So I'd be B prime. There we go. All right, so I've got those two set up and ready to go. All right, and then 5, 2. So for C prime, 5 times 2 is 10. And then 2 times 2 is 4. So I'm going to go 10 and then 4. 1, 2, 3, 4. And that's my C prime. And then my last one, my last coordinate here is D times 2 would be 2, 2, because 1 times 2 and 1 times 2. So go 2 and then 2, and there's D prime. And then I'm going to connect those and connect these. And what do you notice? So we've got a smaller shape, right? And then a bigger shape. Now the shape actually remained the same shape. Like the actual shape of it is the same. Just the size has changed. And we actually call that similar. So dilations, first of all, we should probably write down that we need to multiply the coordinate x and y by the dilation value. And sometimes that's called the factor, just so you're aware. Okay, and then, which kind of has to do with multiplying. So we multiply by that, and then it changed the size, but not shape. And so we actually call this similar. So, for example, if you have a small circle and then a big circle, those shapes would be similar. If you have a small rectangle and then a bigger rectangle, but to the same scale, so maybe this has like a length of 3, but this has a length of 9, then we know we've dilated it by 3 because it's 3 times bigger. So that would be your factor there. So that is our dilations. All right. go ahead and practice your dilation down here, and then check your answers on Schoology. And please see your math teacher if you need additional help on any transformations.